Here we go. We have a question, root to leaf paths sums. So you have given a binary tree where every node value is a number, and we need to find the sum of all the numbers that are formed from root to leaf. This is important, root to only leaf. The formation of a numbers would be like 10 multiply parent plus current. So suppose we have this binary tree, and in this root 6 is our root, and we have 1 2 3 4 leaves. So from 6 we have to go till from root we have to go till leaf. So if we start from here, the value is 6. Then if I come here, the value at this position is 63, then value at this position is 632. So this is our leaf node, we need to consider 632. So this value, and another path is this. So 6 is here, 63 is here, 635 is here, 6357 is here. So that's how we have 4 different paths. So if we sum the value, the answer is this. So the problem description says it all. Let's try to build the approach. Suppose we have the same binary tree, and this is our root. The value, uh, its parent value. So we will build a separate function. So in this function we have two things. First thing is our node, and next thing is the value that we are getting from the parent. If the node at any given position is null, we just need to return 0, not the x value, but return 0. Why? I will tell you why we need to return 0. Uh, so let me tell you, because we need to consider from root till leaf, and if the node is null, means the node value is not the leaf node, so we cannot consider the path. So that's why we have to return 0. So let's start the algorithm. First we have this value. So the parent value initially is 0, and the node is the root node. Then the value at current position, or let's say we are changing our x value, and x value will be parent multiply 10 plus root value. So let me write data here. So here the value will be 6. Next we need to go to its left child, and we need to go to its right child. So we are traversing node dot left with our value x, and we are going on the right side also, node dot right with value x. So if I come here, the node is 3 and x is 6 that we are getting from parent. Now at this current position, x will converted uh, into 6 multiplied 10, which is the parent value. 6 is our parent value, so x is 6. So 60 plus 63 plus 63, we have 63 here. Next we come across this node, the value will be 632. So this is the leaf node, and we need to consider this value. So we have to write a condition here. If this is a leaf node condition is its left child and its right child is null. So we have to write that condition. So I am just writing leaf. If current node is a leaf node, then we just need to return 0, sorry x, the value that we have at this particular position. So we just need to return x. So from this position we are returning 632. Now we have traversed to its left side. Now we are going to its right child. The value at this position is uh, parent value is 63, and here the value will be 635. Here the value will be 6357, and it will return this value 6357. Next we come across this node. This is our leaf node. We have 6354. Then we need to return this node, this value, x value, integer. So at this position we are getting the value from its left child, and we are getting the value from its right child. Means on any given node we are getting the value from its left child, and we are getting the value from its right child. So we need to consider both values. So this is the function that we are calling and this function return us some value. So we need to consider this value, and we just need to return this value. So we have a return statement here, and we need to consider both values. So we have addition. Next we have at this position 6357 and 6354 here. So it will return, let's say, x, the summation of both values, this value and this value. So I am writing x. From left child we are getting 632, and from the right side we are getting x. So it will return some value. So let's say y. We have traversed the left child. We need to traverse to its right child. So the value at this particular position is 65. Then we need to go to its left, because we are calling its left, but its left is null, so we cannot access the data itself. So that's why we have to write one more condition on the top. If the node is null, just return 0. We don't need to consider the current path. Return 0. So from its left child we are getting 0. Next we are going to its right child. Here the value will be 654. We are getting the value. This is a leaf node. It will return some value. Then from this position we are getting 0 and 65. 654. So we need to sum up, and it will return 654. So from the left child we are getting some value, from the right child we are getting some value, and we need to just return the value. So let's say this is our answer. This is answer. And if you carefully observe the function, what is this function? This function does something, then we are calling its left, then we are calling its right. So this is nothing but pre-ordered traversal, simply a pre-ordered traversal. So let me show you the code. Code is very simple. We have just a simple pre-order function. We have pre-order, and we are passing root and value. This is a pre-order. The function is static, so we have to write static here. And we have node and value. If the node is null, return 0. Then we need to find the value till the current node. If this is a leaf node, just return the value, and we need to calculate the value by going to its left child and to its right child. That's about it. Let's submit this. The code is given in the description box. And let's talk about time and space complexity. The time complexity in this case is order of n, because we are traversing every single node. And the space complexity, if you consider the stack space, uh, it will be order of n or order of height. And if you don't include this stack space, then we have to write in by using for loop and separate stack. Then the space complexity will stay same, that is order of height. So let's find out. The time complexity is order of n, and space complexity is order of height. So we have met the expected time and space complexity. If you like this video, give it a thumbs up, subscribe to this channel, and we have successfully completed 200 videos on this channel. And thank you all for your support.